So, good morning, good day to everyone. Good day sa mga Sir Romel. Now we will be discussing about the fuel cells. And in your service, here are the presenters this day. Ako, si Miss Berna Michelle Doque and Mr. Ryan Jose Pangilinan. At the end of this report, we will be able to define what is a fuel cell, differentiate the different types of fuel cells, understand how it works, understand the history, pros and cons of a fuel cells, and learn what are the basic components of a fuel cells. First, let's define what is a fuel cell. A fuel cell is an electrochemical cell that converts the chemical energy of a fuel, typically hydrogen fuel, hydrogen. A fuel cell uses the chemical energy of hydrogen or another fuel to and efficiently produce electricity. And it is further classified primarily by the kind of electrolyte and other factor they employ. And there are several types of fuel cells currently under development. And here are the first example, the direct methanol fuel cells. Direct methanol fuel cells or DMFCs are subcategory of proton exchange fuel cells in which methanol is used as the fuel. So this is the schematic diagram of the direct methanol fuel cells, which as we can see, ang input nato which is ang methanol or water and air exchange sa ato ang electrode present na dani. Next is the alkaline fuel cells. The alkaline fuel cell, also known as the Bacon fuel cell after its British inventor Francis Thomas Bacon, is one of the most developed fuel cells technologies. Alkaline fuel cell consumes hydrogen and pure oxygen to produce potable water, heat, and electricity. So this is the schematic diagram of the alkaline fuel cells. Ang input niya hydrogen, tapos ang output potable water, tapos sa pikas oxygen, purely oxygen. Next is the phosphoric acid fuel cells. Phosphoric acid fuel cells are a type of fuel cell that uses liquid phosphoric acid as an electrolyte. They were the first fuel cells to be commercialized, developed in the mid 1960s and field tested since the 1970s. This is the schematic diagram of the phosphoric acid fuel cells, in which kaning electrolyte is nani siya phosphorus, which pag mo enter ang ato ang fuel, which is a what air and hydrogen, mag combine siya sa ato ang electrolyte, then mag-produce siya og electricity gikan sa anode to cathode. So the next is the molten carbonate fuel cells. Molten carbonate fuel cells are high temperature fuel cells that operate at temperature of 600 degree and above. Molten carbonate fuel cells are currently being developed for natural gas, biogas, and coal-based power plants for electrical utility, industrial, and military applications. So this is the schematic diagram of molten carbonate fuel cells. Next is the solid oxide fuel cells. A solid oxide fuel cell is an electrochemical conversion device that produces electricity directly from oxidizing a fuel. The SOFC has a solid oxide or ceramic electrolyte. This is the um, schematic diagram of the solid oxide fuel cell. Reversible fuel cells. A regenerative fuel cell or the reverse fuel cell is a fuel cell run in reverse mode which consumes electricity from chemical B to produce chemical A. This is the schematic diagram of reversible fuel cells. The last the last one is the proton exchange membrane cells, fuel cells. Proton exchange proton exchange membrane fuel cells, also known as polymer electrolyte membrane fuel cells, are a type of fuel cell being developed mainly for transport application as well as for stationary fuel cell applications and portable fuel cell application. It's, so kaning mga fuel cell, so this is the schematic diagram of the proton exchange membrane fuel cells. Kaning 10 ka fuel cells nga akong i-discuss will be further discussed by the next reporter na si Ryan. Overview lang ning ako Tapos, now let's discuss how the fuel electricity and heat as long as fuel is supplied. A fuel cell consists of two electrodes. A negative electrode, which is known as anode, and positive electrode, which is known as cathode, sandwiched around an electrolyte. A fuel such as hydrogen is fed to the anode and air is fed to the cathode. Application of fuel cells. Fuel cells can be used in wide range of applications including transportation, material handling, stationary, portable, and emergency backup power application. Fuel cells have been several benefits for conventional combustion-based technology currently used in many power plants and passenger vehicles. So previously, fuel cells are used in industrial gas and specialty applications such as rocket fuel and katong akong ingon nga industrial gases. And currently sa current na um, year, gina-develop ang ENE farm which is uh, a residential fuel cells which is ang primary input is hot water and water to produce electricity sa residential. Then fuel vehicles which is some are hybrid electric and full electric vehicle which is powered by fuel cell. Then the future diverse application may be used in several applications such as forklift trucks, buses, power plants, airplanes, scooters, and rail cars or real vehicles. So, let's focus sa karon sa since mechanical engineering technologies man ta. Let's focus usa diri sa application sa fuel cells on the vehicle. So this is the hydrogen fuel cell electric vehicle. So the key components of a hydrogen fuel cell electric car is first the battery, which is an auxil wait sorry which is the auxiliary battery that will provide electricity to start the car before the traction battery is engaged and also powers vehicle accessories. So the second is the battery pack. This stores the energy generated from the regenerative braking and provides supplemental power to the electrical traction motor. Next is the DC-DC converter. This converts higher voltage DC power from the traction battery to lower voltage DC power needed to run the vehicle accessories and recharge the auxiliary battery. Next is the electric traction motor. The electric traction motor using power from the fuel cell and the traction battery pack. This motor drives the vehicle wheels, and some vehicle uses motor generation that perform both the drive and the function regeneration. Next is the fuel stacks, an assembly of individual membrane electrodes that use hydrogen and oxygen to provide electricity. Next is the fuel filler, also fuel dispenser, and be the mechanical power from electrical traction motor to drive the wheels. So uh, full representation sa ilang tanan, no? This is the battery pack, the fuel
Hey everyone, so this is Bernardo and I'll be reporting about the history of the fuel cells. So fuel cells was formed or invented by a chemist named William Grove in 1839, and he was a chemist, physicist, and lawyer is generally credited with inventing the fuel cell. And he was also conducting a series of experiments with what he termed a gas voltaic battery, which ultimately proved that electric current could be produced from an electrochemical reaction between hydrogen and oxygen over a platinum catalyst. Then over time, it was the term fuel cell was formed by Charles Langer and Ludwig Mond, who researched fuel cells using a coal gas as a fuel. Further attempts to convert to convert coal directly into electricity were made in the early 20th century, but the technology generally remained obscure. And in addition, Cambridge engineering professor Francis Bacon modified their invention to a equipment to develop the first AFC, but it was not until 1959 that Bacon demonstrated a practical 5 kilowatt fuel cell system. At around the same time, Harry Carl fitted a modified 15 kilowatt Bacon cell to an Allis-Chalmers agricultural tractor. Allis-Chalmers, in partnership with the U.S. Air Force, subsequently developed a number of fuel cell-powered vehicles, including a forklift truck, a golf cart, and a submersible vessel. Next is about the fuel cell advantages and disadvantages. So, number the major advantages of this is it is eco-friendly because it does not have a much emission that will cause a air pollution, and it only had and also it has no carbon dioxide emissions and no air pollutants that create smog and cause health problems. And it is high efficiency when utilizing cogeneration. Fuel cells can attain over 80% energy efficiency, and good reliability. Quality of power provided does not degrade over time, and it has no noise pollution. So when it will be used for engine, then probably it would be no much there's no much noise in it. And then the size reduction, because the fuel cell can be compressed, or in other term it is compressible. And disadvantages is producing a fuel cell can be can be costly because it is in fact it is expensive to produce catalyst platinum, and it has a lack of infrastructure to support the distribution of hydrogen. And currently, we don't have much available um, fuel cell technology is in the prototype stage and not yet validated. And it is much expensive to the point that the cost of operating will be every 1 kilowatt fuel cell for 7.26 hours when only one cylinder is purchased per month is will cost $134, and this is equivalent to 18.40 per hour to dollars per hour to operate at 1 kilowatt. So that will be my report.
So the next we are about to present is the limitation of a fuel cells. Uh, the limitation of a fuel cells. So a fuel cells is the technology that nowadays is deemed having a great potential to be used in supplying energy. So basically, fuel cells can be categorized particularly by the kind of employed electrolyte. Several fuel types are which are currently identified having huge potential to be utilized, namely solid oxide fuel cells, molten carbonate fuel cells, alkaline fuel cells, phosphoric fuel acid fuel cells. So in general, each of the fuel cell types has their own characteristics and specification which assign the capability and sustainability of them to be utilized for any particular applications. Uh, there are two most significant application currently aimed for the fuel market. So it is generally accepted that there are a lot of advantages of fuel cells that can be excessively commercialized, primarily in context of environmental concerns and energy security. So nevertheless, this is demanding task to be accomplished as there is some gap in fuel cells technology itself, which needs a major enhancement. It can be concluded that cost, uh, which you said a while ago, durability and performance are identified as the main limitations to be firstly overcome in enabling fuel cells technology become viable for the market. So the next we're talking about is the materials for fuel cells. So the first material is the alkaline fuel cells. Fuel cells. These fuel cells are easy to handle, have a very high electrical efficiency, and are very suitable for dynamic operating modes. They can be built into small compact system as well as into large plants. However, many groups in Europe have stopped working on this technology, as well as the advantage, uh, as well as the advantages of the fuel cells and the disadvantages. Uh, so the AFC has the highest electrical efficiency of all fuel cells, but it typically uses very pure gases. This is often considered a major constraint for most applications. However, the restrictions are probably not that important. The stock design of AFCs is different from the most common designs of polymer electrolyte or solid oxide fuel cells. Alkaline fuel cells contains a liquid electrolyte in most cases. Therefore, in principle, the cell has three chambers that are divided by electrodes or separators. So that was the alkaline fuel cells. The next one is the polymer electrolyte membrane fuel cell. So this fuel cell is a basic setup of a polymer, and it is lined with the two electrodes that are separated by means of an electrically insulating but ionically conducted membrane. In a PEM fuel cell, the anodic reactant is hydrogen, which is oxidized to form protons at the cathode. Oxygen is reduced and forms water, uh, water with protons that are transported through the proton conductive membrane. Successful operation of PEMFC is a system challenge. The component and operating condition of the system must be adapted to the requirements of the application. Integration of PEMFC system involves a plenitude of auxiliary equipment. A system controller must take care to maintain optimum operating conditions with respect to power and endurance. An example of this, an example of a PEMFC is in a brass board setup. In a brass board setup. So this system uses cathode recirculation for humidity control, including thermal management, electric power conditioning. So the system can apply under unregulated and regulated DC as well as AC. So the next one is the direct methanol fuel cells or DMFCs, which represents the only class of fuel cells in which one of the reactant is provided in liquid phase, unlike the other gas-fed cell types. Owing to the comparatively easy handling of the methanol, the DMFCs are mostly considered for portable and mobile application. The reduced power density compared with hydrogen-driven uh, hydrogen-driven polymer electrolyte membrane fuel cells, or PEMFC, usually leads to larger stack sizes at similar power characteristics. So methanol cartridges are much easier to handle than hydrogen storage media, given giving them an advantage in fuel transport. So as the material requirements are comparable to hydrogen-driven PEMFCs, the components employed are in general very similar or even identical to this fuel cell type. So the fundamental steps of the electrochemical methanol oxidation reaction describes requirement for catalyst employed in DMFCs, followed by the gas diffusion media, flow field consideration, and finally system requirements and performance aspects. So that was for the direct methanol fuel cells. The next one is the phosphoric acid fuel cells. So these fuel cells is advances in materials have largely driven the development of fuel cells, and that there is no exception. So the liquid nature of the phosphoric acid electrolyte makes establishing a stable three-phase interface critical to achieving good power density and to the long-term operation of PAFCs, particularly at high current densities. Material structures and processing methods to improve and stabilize this contact have been critical in the development of PIFCs. With the exception of membrane degradation, PIFCs have faced virtually the same challenges during their development over the past couple of decades. As the developers move toward higher temperature of proton exchange membrane fuel cells, the lesson learned from PIFCs becomes more and more relevant. So PIFCs are best suited for installation where the waste heat can be used or in application where premium power is needed. Although the majority of installation operation of natural gas, PIFCs operating on hydrogen, propane, and digester gas have been demonstrated. Thus, stationary application of PIFCs have been and are expected to continue to dominate for the foreseeable future. So, the next is the molten carbonate fuel cell. This fuel cell is the employment of a molten salt electrolyte distinguishes the molten carbonate fuel cell from other hydrogen-oxygen fuel cells. So the MCFC offers considerable opportunities, especially for medium to large scale power generation due to high due to their highly efficient conversion efficiency, potential for cogeneration, and added bottoming cycle. Quiet operation essentially clean products with low environment impact. So compared with other fuel cell technologies, the MCFC has the steepest polarization curve. This means it is the advantageous at lower current densities operations, resulting in relatively low pressure densities. So the next is the uh, regenerative fuel cells, which is a single device or system capable of functioning either as an electrolyzer or fuel cell. So RFCs comes in two basic types. These are the discrete regenerative fuel cells or DRFCs and unitized regenerative fuel cells or URFCs. In a DRFC, the device used to perform the electrolysis is separate to that used as a fuel cell, but these two devices are both integrated into a single system. A URFC is likewise a single device that can work in either electrolyte, electrolyzer mode or E mode or fuel cell mode, FC mode. The vast majority of URFCs built to date have employed a proton exchange membrane as a solid electrolyte. Falling between the URFCs and DRFCs concept is a regenerative fuel cell in which a fuel cell stack is joined directly to the electrolyzer stack. So therefore, the two stack are in line and from a single unit, although separate cells are still in E and FC mode, E modes and FC modes. Right. So this lang. Uh, Fuel cells have a strong benefits over conventional combustion based on technologies currently used in many power plants and cars. So they produce much smaller quantities of greenhouse gases and none of the air pollutants that create smog and cause health problems. If pure hydrogen is used as a fuel cell emit only heat and water as a byproduct. Hydrogen-powered fuel cells are also far more energy efficient than traditional combustion. So in the future, fuel cells could power our cars with hydrogen replacing the petroleum fuel that is used in most vehicles today. Because many vehicles manufacturers are actively researching and developing transportation for fuel cell technologies. So that is all about fuel cells. So muna to ang report sa kanang fuel cells nga i-discuss na namo kanina regarding with this history, advantages of the fuel cells, materials, limitations, future of fuel cells. So thank you for all listening. God bless.